Okay, so a lift of mass 600 kilograms is lowered by means of a cable attached at its top. When carrying passengers with total mass of 400 kilograms, the lift accelerates uniformly at 0.4 meters per second squared. Find the tension in the cable if the lift is moving downwards. So in this case now, we've got our lift. So we're given the acceleration, but it's moving downwards. Okay, so I'm going to have the direction of motion of the lift heading down, 0.4. Now, we need to find the tension in that cable, and of course then the weight will be the combined masses of these, so 600 and 400 for the passengers, so that's 1,000 kilograms, and of course then is mass times g. So if we apply Newton's second law, remember it is in the direction of increasing motion. Okay, so essentially it's going downwards, yeah? The lift is going down. So in a sense, you want to think of this as like the driving force. So that weight there has to be greater than the tension in the cable, if you think about it. In order for the lift to actually drop, okay, or move downwards, the tension cannot be greater. Because if the tension was greater than 1,000 G, it would lift it. Would move upwards. So in the case of it moving downwards, the weight is greater than this. So this is the downwards is the positive direction. So in terms of resultant force, we've got the leading force, so the driving force would be the weight of this lift, which would be 1,000 G, and then we take away then what's resisting it. So the pull of that cable is resisting it. Of course, we still need to have the cable there, yeah, we need to have that resistance, otherwise it's just going to drop, isn't it, under gravity. So there will be tension in that cable, but it will be less than the weight, so that it ends up moving downwards. So the mass then of the overall includes the lift and the people, so that's just 1,000 kilograms, so just 1,000, right? Do not put 1,000 G, because it's just the mass, so we want the kilogram mass, which will be 1,000, and then times then A, so A we know is 0.4, okay? So 1,000 times 9.8 for G, take away T, and then 1,000 times 0.4 is 400. This then becomes 9,800 equals 400, and then if you rearrange that, we end up getting T to be 9,400 newtons. So you could see then that it's actually less than the weight